So looking at a linear function, y equals absolute value 2x minus 3, in order to graph this out, we can't rely on the graphing calculator. It doesn't have the absolute value function that we need, but we can use it as a tool to get us the graph. So question A, we need to find the x-intercept and develop a table of values. Well, the x-intercept happens when y equals 0. So whenever we have to find the x-intercept, we'll plug in a 0 for y. Splitting this equation is not necessary because we would split it into 0 equals and negative 0 equals. Well, there is no such thing as negative 0, so we just have one split when the absolute value equals 0. Solve that equation, we'll add 3 to both sides. Divide by 2, x is equal to 1.5. So the x-intercept happens at 1.5, which we're going to use as the basis for the table of values. So we have an x, we will have 2x minus 3, and we'll have the absolute value of 2x minus 3. The reason for the 2x minus 3 without the absolute value is that's where the calculator comes in. So if we go to the calculator, we go to y equals, and we enter 2x minus 3. Normally what we'd do with this is we'd graph it, but if we look above the graph button in yellow, we have a table option. This actually helps us create the table of values. So we go second and graph to develop a table. Now what we can see is that there is no x-intercept. There's no place where y equals 0. Because the calculator defaults to whole numbers for x's, that's why we had to solve for the x-intercept first. What we will do is we'll take a 1.5, I'm putting it in the middle of the table because I want a couple of points left of it and a couple of points right of it. That gives us 0 and 0. A couple of points on the left would be 1 and 0. A couple of points on the right would be 2 and 3. And these values for the second column, we just look up from the calculator. So at 0, y is negative 3. At 1, y is negative 1. At 2, y is 1. And at 3, y is 3. To get the last column, we simply take the absolute value of the previous column. So the absolute value of negative 3 is 3. Absolute value of negative 1 is 1. Absolute value of 1 is still 1. Absolute value of 3 is still 3. Question B, to sketch the graph, we need our x column and our absolute value of 2x minus 3. Those two columns will give us our points, x and y. So when x equals 0, y equals 3, put a point. When x is 1, y is 1. When x is 1.5, y is 0. X is 2, y is 1. And x is 3, y is 3. To sketch this out, we need to keep into account what this function was before we applied the absolute value. It was a line. So when we make this into an absolute value graph, it will still be basically a line, but it's going to have a vertex or a point at the x-intercept. So the graph essentially is going to make a V. Question C, I'm going to do above the graph. The domain and the range. The domain of this function, we need to look at what was the domain of the original function, the original line. Domain of all lines is all real numbers, so x can be any real number. The range, however, absolute value functions never go below the y-axis, they always just go above. So for the range, y is greater than or equal to 0. Question D, a piecewise function. We'll have y equals, we'll need to open up the bracket because we will now have two equations defining this function. The first one is always the original function without the absolute value, so 2x minus 3. The second one is always the negative of that, so negative 2x minus 3. And now we need to apply the conditions. So y is 2x minus 3 for the parts that we didn't have to change the sign on the absolute value. So in that case, that was when x was greater than or equal to 1.5. The part where we have the negative of the function, this is the part on the table where we did have to change the values due to the absolute value. So in this case, if x is less than 1.5.